Good morning to all. Today we learn about simple cubic and body-centered cubic crystal structure. At first, the simple cubic crystal structure. Figure shows the unit cell of the simple cubic crystal structure. First we find out the number of atoms per unit cell. We know that in the simple cubic lattice, there are 8 atoms at the 8 corners. Please see the second diagram. There are 8 atoms at the 8 corners. In the lower level 1, 2, 3, 4. In the upper top level 1, 2, 3, 4. So 4 plus 4, 8. In the simple cubic crystal structure, there are 8 atoms at 8 corner. Each atom shared by the 8 unit cell. See the third diagram. The third diagram is the three-dimensional view of the simple cubic crystal structure. Here we consider the corner atom. There are in the horizontal plane 1, 2, 3, 4, 5, 6 lattice point shared, and then upper one and then side one. So 6 plus 2 is 8. So there are 8 each atom shared by the 8 unit cell. Therefore, number of atoms per unit cell, we know that there are 8 atoms each shared by the 8 unit cell. So 8 into 1 by 8 is equal to 1. So finally we found out the number of atoms per unit cell is equal to 1 in the simple cubic crystal structure. Next one, we find out atomic radius. If A is the length of the side of the cubic cell, because it is cube, all the sides are equal, we consider A is the length of the side of the cubic cell and R is the radius of the atom. So we find out the nearest neighbor distance 2R. 2R is equal to A. We want R. So R is equal to A by 2. Next, third point, coordination number. How to calculate the coordination number? Here we consider the corner atom, any of the corner atom. We consider here the corner atom A. From the diagram we consider the corner atom A. Here the corner atom A touches the 4 nearest neighbor atom in its own plane. Suppose 1, 2, here they are mentioned in the diagram 1, 2, 3, 4. 4 atom in its horizontal plane and 1 atom above the plane and 1 atom below the plane, vertically above the plane and vertically below the plane. So totally 4 atoms in its horizontal nearest neighbor atom, 1 atom vertically above it and 1 atom vertically below it. Hence the coordination number of the simple cubic crystal system is 6. Then we calculate the atomic packing factor. What is atomic packing factor? We are already discussed in the previous class. Yes, you are correct. Atomic packing factor is nothing but ratio of the volume of all the atoms in the unit cell to the volume of the unit cell. Then volume of all the atoms in the unit cell can be expressed as number of atoms into volume of one atom and then divided by volume of the unit cell. We know that the number of atoms in the simple cubic crystal structure is 1. So 1 into volume of one atom. The atom is in sphere shape. So volume of the sphere is 4 by 3 pi r cube. So 1 into 4 by 3 pi r cube divided by volume of the unit cell. The value of volume of the unit cell is A cube. How it is found out? A cube. What is A cube? A cube is the volume of the unit cell. In general, volume is equal to length into breadth into height. So in the cube all sides are equal. So A into length A, breadth A, height A. So A into A is equal to A cube. So volume of the unit cell is equal to A cube. Then it can be simplified as 1 into 4 pi r cube. 3 is taken in the down, 3 into A cube. Substitute A value. What is A value? A value is 2R. So 2R the whole cube. So simplifying this expression we can get pi by 6. So pi by 6 is equal to 0.52. So packing factor of simple cubic crystal system is 52%. So finally we conclude that the atom occupy 52% of the volume and the remaining 48 is vacant. So simple cubic crystal structure is a loosely packing one. The examples of the simple cubic structure is polonium. Here we noted that only one element in the periodic table exists in the simple cubic crystal structure. Next we discussed about body-centered cubic structure. Here the figure represents the unit cell of the body centered cubic structure. First, already we know that there are 4 points we need to calculate the atomic packing factor. One is number of atoms per unit cell, atomic radius, next volume, and then coordination number. So number of atoms per unit cell. First we find out the number of atoms per unit cell. In the body centered cubic structure there are 8 atoms at the 8 corners, and then in additionally 1 atoms at the body centered. This body centered atom is entirely within the unit cell, so it does not share any unit cell. So therefore number of atoms per unit cell in this body centered cubic structure, that is BCC structure, is 8 atoms into 1 by 8. 8 atoms in the at the 8 corner, and each atom is shared by the 8 unit cell. So 8 into 1 by 8 plus 1 atom at the body centered. These atoms are entirely placed within the unit cell, so it does not share any unit cell, so plus 1 only we put. So 8 into 1 by 8 plus 1, so next 1 plus 1, so finally 2. So the number of atoms per unit cell in the body centered cubic structure is 2. Next we learn about atomic radius. Atomic radius. Here we consider the diagram. Diagonal diagram. Center atom is the body centered atom, and then corner atom is the corner atom. We consider the diagonal part, that is A and then D. Here we found out the two triangular part. One is ABC, another one is ACD. So if we consider A is the length of the cube of the unit cell and R is the radius of the atom, consider the first triangle ABC. Using Pythagoras theorem, AC squared is equal to AB squared plus BC squared. What is here AB squared? Yeah, you are correct. AB squared is equal to A squared, and BC squared is also A squared. So A squared plus A squared is equal to 2A squared. So AC squared is equal to 2A squared. Then we consider the second triangle, next top triangle ACD. Here we can apply the same Pythagoras theorem, that is AD squared is equal to AC squared plus CD squared. AC squared already we found out, that is 2A squared. CD squared from the diagram A squared. So 2A squared plus A squared is equal to 3A squared. And then AD squared, it is a diagonal part. It consists of full center atom, that is 2R. The diameter is 2R, and then here the corner atom is R plus R. So 2R plus R is equal to 4R. So AD value is equal to 4R. AD the whole squared is equal to 4R squared. We square the value, 4R squared we get 16R squared. So 16R squared is equal to 3A squared. R squared is equal to 3A squared divided by 16. We want R. What we do? Simply take the root. So root 3, A squared is cancelled, that is A square is cancelled, only we get A. So 16, square root of 16 is equal to 4. So R is equal to root 3A divided by 4. Our aim is to calculate the lattice constant for the derivation purposes. So A is equal to 4R divided by root 3. A is equal to 4R divided by root 3. Next one, we calculate the coordination number of the simple cubic structure. Note out the diagram. Here the center atom is in the green color. Here all the corner atom is in the same distance with the center atom. That is, the corner atom do not touch with each other. Any corner atom do not touch with each other, but all the corner atom is touches with the same distance in the body centered atom in the body diagonal. So how many corner atoms are there in the body centered cubic structure? Yes, you are correct. 8 corner atoms are there. So totally the coordination number of the BCC structure is 8. Next, the last point, atomic packing factor. We know that already we are discussed what is atomic packing factor. Atomic packing factor is the ratio between the volume of all the atoms in the unit cell and volume of the unit cell. And then volume of all the atoms in the unit cell can be rewritten as number of atoms into volume of one atom divided by volume of unit cell. How many atoms in the BCC structure? 2 atoms. So 2 into volume of one atom. What is volume of one atom? Yes, you are correct. 4 by 3 pi r cube divided by volume of the unit cell A cube. Then substitute here A cube value, that is A value. What is A? We are already found out. That is A, 4r divided by root 3. So 2 into 4 pi r cube divided by 3 into 4 pi r root 3 the whole cube. Simplify this equation, we get pi root 3 divided by 8. Pi root 3 divided by 8 we calculate, finally we get the value 0.68, taking the percentage. So packing factor is 68%. When compared to SC structure, it is closely packed structure. SC structure value 52%. So BCC value 68%. So when compared to SC structure, it is closely packed structure. What are the examples of the atomic packing factor? It is the examination point of view. The examples of the atomic packing factor, examples of the BCC structure is sodium, ion and chromium. Sodium, ion and chromium, tungsten are the examples of the BCC crystal structure. Thank you.